2.5 Application of content from the foundation level in the context of ISO 262. ISO 262 offers the tester specific recommendations for test activities in the form of methods tables. These can be found in parts 4, 5, 6, 8, and 12. Apart from functional safety, specific recommendations for test processes and test activities, they also include the test techniques to be used. In this context, the standards use the term methods related to all applicable test techniques or test activities. At this point, the functional safety terminology differs slightly from the terms of the ISTQB. For the tester, the following methods of the ISO 262 are of special interest: test techniques, equivalence partitioning, and boundary value analysis. Test techniques for test execution, simulation or prototype of a component or system. Test types, non-functional tests such as performance testing and endurance testing. Test environments, hardware interlock, and workloads. Status test techniques, reviews, and status analysis. The methods tables define the methods recommended by the standards for each issue level. They are always designed in the same structure. Example of a methods table. For each method, depending on the issue level, it is documented whether its use is recommended plus or even highly recommended plus plus. For methods marked as optional 0, there is no recommendation provided by the standard form, or again its use. ISO 262 also lists equivalent alternative methods in the method tables using letter suffixes. In the example above, routes 3A and 3B. Here, the tester needs to choose a suitable combination to be able to verify the relevant requirements in an issue-compliant way. The tester must justify the usefulness of the selected combination. In the case of methods without alternatives, routes 1 and 2, this option of choice is not permitted. Here, the tester must apply all methods that are highly recommended for the respective issue level. For example, when verifying a requirement according to issue C, the following methods are reserved from Table 1. Method is highly recommended, so it must be applied when developing in accordance with ISO 262. Method E, recommended, so it should be applied, or a rationale for not applying the methods. Methods has to be given. Methods yes 1 and yes 2. Here, at least methods yes 1 should be chosen as it has the highest level of recommendation for RQC. ISO 262 also allows the tester to use other methods than the ones listed in the method tables. In this case, the method chosen must be justified for its usefulness and suitability. Generally, ISO 26262 allows to customize the safety activities to fit the specific needs of the particular project, tailoring for task-related activities. This means that the test strategy and test approach can be tailored to the specific project. 3. AUTOSA. AUTOSA stands for Automotive Open System Architecture. AUTOSA involves the architecture and the development partnership behind it. The AUTOSA partnership was established in 2003 and includes mainly OEMs and suppliers from the automotive industry. The goal of the partnership is to jointly develop and establish an open industry standards for automotive software architecture. Today, AUTOSA is a standard established globally for automotive EE systems. Therefore, the tester certainly encounters AUTOSA work products. For the tester, it is important to know the project objectives of AUTOSA, the general structure of the AUTOSA architecture, and their influence on the work of the tester. 3.1 Project objectives of AUTOSA. The following are the project objectives of AUTOSA. Support the portability of software. Support the scalability across different architectures and hardware variants. Support different functional domains. Support data exchange with non-AUTOSA systems. Define an open architecture for automotive software. Support the development of dependable systems characterized by availability, reliability, safety, integrity, maintainability, and usability. Support the collaboration between partners. Support applicable international automotive standards and state-of-the-art technologies. 3.2 General structure of AUTOSA. There are two architecture variants in AUTOSA, classic and adaptive. For simplicity, this syllabus focuses on AUTOSA classic. An AUTOSA system typically consists of several electronic control units, ECUs. On its ECU, the software architecture of AUTOSA classic consists of three layers. The top application layer is hardware independent. A component of this layer is called AUTOSA software component. The bottom hardware-oriented layer is the standardized basis software. The intermediate abstraction layer is the AUTOSA runtime environment (RTE) as a kind of middleware. It implements the data flow between software components and as well as between software components and basis software. In the AUTOSA methodology for developing automotive systems, OEMs and suppliers exchange system information using description files based on AUTOSA templates. So, called RXML files. The ECU configuration description includes data for the integration of the software components on a single ECU. The system configuration description includes data for the integration of all ECUs in the vehicle. The ECU interrupt includes the data from the system configuration description for a single ECU. 3.3 Influence of AutoSAR on the work of the tester. AutoSAR influences the work of the tester, especially at the following test levels: software component testing and software integration testing. In a virtual environment, software in the lab, using a simulation of the basic software and the RTE, the tester can test software component early. Software component testing and software integration testing in the real ECU. Here, the tester gets access to the combination on the RTE. Thus, the tester can observe and control the behavior of a software component at runtime. The AutoSAR acceptance test is the test of the software system which ensures the compliance of the AutoSAR functionality at the communication and application levels. The execution of the AutoSAR acceptance test is optional. System integration testing. Integration of various ECUs, for example, to test functionality whose implementation is distributed over various ECUs by simulating not yet implemented functionality. The tester can access the system behavior early. For comparison of A-SPI, ISO 262 and foundation level. 4.1 Objective of A-SPI and ISO 262. There are several standards that propose requirements for product development. Typically, these highlight different aspects in the development. In this subsection, ISO 262 and A-SPI are compared regarding their objective. ISO 262 has the objective of avoiding risk from failures in both hardware and software by providing suitable requirements and processes. For the development of EE system, it defines the requirements for the test processes and methods to be used by the tester. These depend on the issue level of the item. A-SPI serves as purpose of determining the capability of the product development process within the framework of assessments. To do so, A-SPI defines accessible criteria for these processes. In contrast of ISO 262, these are independent of the product's issue level. 4.2 Comparison of test levels between A-SPI, ISO 262, and foundation level. Both ISO 262 and A-SPI describe test levels. However, these are not fully consistent with the test levels from foundation level. Therefore, for an efficient and effective collaboration Within the development team, testers should have a common understanding of all test levels. The term system used in a SPICE and the terms system and ISTQB used in the ISO 26262 refer to a product consisting of hardware and software components. The foundation syllabus, however, refers to software only when using the term system. Therefore, the test levels of ISTQB can be mapped to the test levels in ISO 26262 and a SPICE as follows. Note that in the ISO 26262 column the numbers Note that in the ISO 26262 column the numbers in parentheses refer to a specific part of the ISO 26262 standards and to a particular chapter therein. In the SPI column, the parenthesis shows the respective process ID, a segment of test levels. In the ISTQB Foundation level syllabus, most test techniques can be used at the different test levels. Similarly, a SPI does not generally assign any test techniques to test levels. Therefore, both leave the choice to the testers. In ISO 26262, there are individual methods tables for each test level. These provide the tester with recommendation of test techniques based on the issue level.